Hello friends, welcome to the channel of Digital to Real. Today I am going to discuss about the randomization concept in System Verilog verification. Okay, we know that System Verilog is a HVL language. It is a hardware verification language where OOPS concepts are used. Now, here in System Verilog verification, how randomization is done, that we will see. So, what is the need of randomization in design verification? So, when we design a circuit based on our design document or design specification document, we anticipate certain number of bugs. Because we are very much aware of that, while coding we might have left some of the loopholes where there is a possibility of bug. And we write the test cases in order to design the circuit based on our assumption that yes, these are the bugs which are present in the code. But now, if the complexity of the Verilog code or complexity of the design circuit is very much, means very big circuit, then it is out of the reach of our anticipation to know what are the various bugs which is present in our code. So randomization plays a very important role for verifying such big circuits, which is beyond the imagination of our limited brain. So when we do directed testing means we are testing the bugs which are anticipated. So we see a linear progress in testing with time. For the whole circuit, to make sure it is fully tested, we might have set some expectation. Yes, this feature you have to cover, then next that feature, then next that feature, third feature, fourth feature with respect to our design document. And while writing the directed testing, linearly we move towards our goal. Now, when we do random testing, we'll go for or we check for the unanticipated bugs. And when we do so, actually the progress towards the testing of the circuit is very much better than the linear progress. There can be exponentially increase in the verification. So this verification and design of the ASIC circuit actually goes parallelly. Therefore, we have dedicated verification engineer just like dedicated design engineers for the ASIC and FPGA. So what happens is that same design document or specification document is being sent to the design team also, is sent to the verification team also. They are very independent to each other. They are independent teams. And the verification engineer look into the specification from the verification point of view, while the design engineer look into the specification from the design point of view, independent to each other. So, if a verification engineer does the design, what happens is that we are ourselves getting biased towards design because we have written the design. So, when we have the independent teams, what happens is that there is no bias. Everyone is doing their job dedicatedly. And there is a possibility or there is a much better and much higher increase in the verification or getting a very much fault-free design code with the two less faults or two less errors. In directed testing, as we are looking and checking only anticipated bug, we do very little upfront work, means very less homework we do. Means what are the possibilities of error which can come. So these are the things we do very less in direct testing. So no upfront work, no homework or very less homework. While we do the random testing, we do too much upfront work, too much homework in order to complete the testing as soon as possible and with minimum number of errors possible in the design code. Because we have to every time find an error we have to send it to the design team will recorrect it, the design will come again to the verification team, they will again check the code of test cases. So this way there is a to and fro of the information from the design team to the verification team to the design team. Okay, because once the chip is ready, nothing can be done. So this figure shows on the y-axis we have the test plan completion, and here in the x-axis I have the time. You see this one, the black staircase is for the linear progress, that is for anticipated bugs, that is direct testing. While this particularly red staircase, it shows the exponentially increase in the verification. It shows the random testing. Now, how can we cover the untested areas of design? More random testing with tighter constraint. And directed testing means we are not fully removing the directed testing. We are keeping the directed testing also. Apart from that, we are including the random testing also in the verification. And even after including the random testing, we are not generating the fields simply randomly. Suppose the width of the field is 31 down to 0. So, if I consider the randomness in taking the value for that particular variable of 32 bits, it can take 0 to 2 raised to 32 only. So, this much randomization is not required. So, I have to put tighter constraint in that also. So, in order to test the design code, we will include the directed testing, we will include the random testing, and in random testing, we will put the constraints, tighter constraints. When can we say that our design testing is complete? So, there are two concepts involved. One is the functional coverage and another is the code coverage. When functional coverage is 100% and the code coverage is 100%, at that time we will say that our design is complete. Now, code coverage is what? There should not be any redundant code. All the statements should be covered in the code. We have tools for that in order to check for the code coverage. For functional coverage means the code which we have written, it should cover all the features involved in the specification. So functionally it should be 100% correct or 100% covered, and code coverage means code also remain 100% covered. There should not be statements or pieces of code or block of code which is not covered in the code coverage. So what happens is that in this way the design is also, there is no redundant piece of code. Design is also clean and functionally also fully covered. Now what are the fields or attributes which are randomized in test bench? That we will see. We will list out what are the attributes, what are the fields, what are the components, what all we can do in the randomization. First point, design configuration. This we can randomize. Environment configuration, that also we can randomize. Primary input data, that also we can randomize. Encapsulated input data, that also we can randomize. Encapsulation is the concept of OOPS, where data hiding takes place. Not only the data hiding, data regrouping takes place, grouping of the data. Related attribute with a related method in the class, they are put together, that is called encapsulation. So encapsulated input data is also randomized. We will do the randomization for protocol exceptions. We will do randomization for errors and violations. We will do randomization of the delays. We will do randomization of the test order also. Suppose 10 or 20 or 30 tests we have written in order to check the environment of the test. And not to check the environment of the test, but to check the design. So this the order of the test cases. Which one will be coming first, which one will be coming second, which one will be coming last. The order can also be randomized. And seeds for the random tests. This is another concept of randomization we will see afterward. So seat for the random test can also be randomized. So these are the things which can be randomized in the test bench. Now we will see the concept of randomization of the SV classes. So the variable which are declared with rand keyword and randc keyword, they does the job of randomization. Means with randc and rand keyword, we are enabling the randomization in the classes. Variables which are declared with rand keyword distributes values uniformly. Distributes value uniformly means rand bit 1 down to 0 y. So value of y can be 0, 1, 2, 3. So there is an equal possibility of value of y coming as 0, 1, 2, 3 when we have put rand. Okay, the equal possibility. I cannot say that once the 0 value has come for y, next time during the next iteration the value of y will be not 0. There can be repetition of the value of y, same value of y also. Okay. Just like you see 3 2 0 0 3 1. So 0 0 is repeated 2 times. So this is very much possible when we declare one variable with rand keyword. Now variable declared with randc keyword, they distributes the value cyclically. Cyclically means what? Means the values which will be taken by, just see, there is no repetition in y value in an iteration. Means y should take the value, first it will take the value 0, 3, 2, 1. There is equal possibility for 0 coming, 3 coming, 2 coming, 1 coming. But only after this 0, 3, 2, 1, all the possible values of y is covered, then only I can have again the 0 value. Or I can have against the 3 value, 2 value, 1 value. Matlab all the values of y 0 to 3 are covered cyclically. Not cyclically, you need not to have in the order of 0, 1, 2, 3 only. But the thing is that same value is not repeated in the iteration. That means in order to enable randomization on the variable, we have to declare variables as either rand or randc that we have discussed. The difference between the two is that randc is cyclic in nature. And hence, after randomization, the same value will be picked again only after all other values have been applied. Now constraints are specified with the keyword constraint. Okay. Suppose we have a constraint for the bit that y value, the bit 1 down to 0 y. So I have put constraint for that. So constraint y underscore c, name of the constraint. Now inside this curly bracket, I have put y, the value of y should be greater than equal to 1, semicolon, and y should be less than 3, semicolon. These constraints I have put. These are the two expressions of constraint. That means when we are randomizing the value of y, we have to make sure that it should be greater than 1, first thing. That means it cannot be 0. So it has to be greater than equal to 1. So 0 is not possible. And it should be less than 3 also. Means 3 is also not possible. So what are the values of y possible? 1 and 2. So this is how the constraints are put. New value selected when randomize function calls. So this particular function will call, then the value of y will be randomized. The fields are randomized when particularly this function is being called. Randomize. This function returns 1. So the return value of the function is 1. When the constraints are solved, the class where the variables or attributes have been put and rand keyword has been put against them, and also constraints are also included in the class for those attributes. when we instantiate that particular class, we instantiate, make an object of the class in some other class, and we call the randomize function, then the variables or the attributes actually get randomized and constraints are solved. If constraints are solved properly, this randomize function will have the return value of 1, otherwise 0. So we put it like that, class handle dot randomize. This is the way how this randomize function is used. For class instance, that is the class handle, I have to put name of that, then dot randomize. Then it will do the randomization of the fields in the class. Now here is a simple class example is used which shows the random variable. Class packet, semicolon, rand bit 31 down to 0 src, comma dst, comma data, that also size of the data is 8, semicolon. Randc, bit 7 down to 0, kind, semicolon. Constraint C, inside the curly bracket src should be greater than 10, semicolon, src should be less than 15, semicolon. This is the constraint expression, and here is the end class for this class. So the fields in the packet are src, source, dst, destination, and the data. Suppose this is the packet, I have to send from the source to destination. So I will provide the source address, I will have the destination address, and I will provide the data also. 8 data, the array, size of the array is 8. 8 set of data I have to send for the packet. Randc, kind is of having the keyword randc, and the field kind has a width of 8 bit. Constraint is provided for src, source address, the constraint has been provided. There is no constraint for dst, destination address, or data, that any value it can take based on the randomization, because rand keyword is put. Now suppose in another class this packet P is instantiated. Then inside the initial begin and what I will do? In another class I say, or another module, the packet P has been instantiated. P is the class handle packet. Now I have to build the packets inside the initial begin and I am calling the constructor new function. So P is equal to new bracket semicolon. Then I have to check if now the randomization. If P dot randomize I do, it is successful. That is 1, not a 1 is 0. Then there is no $finish statement. There is no need of doing the $finish. If it is unsuccessful, this means this function is giving the return value of 0. Then I have to go out of the module. $finish will be called. If randomization is successful, I will call a function transmit and will transmit the packet P. Semicolon and end for this begin. I will write the test case. What I will do, I will put a macro there. And with that macro, what I will do, I will display the content of randomization. So checking the result from the randomization from test.sv. The extension of the sv file is .sv. So I have a test case, test.sv. From the test case, I am providing a macro. See, the test.sv file check the result of a call to randomize. Test.sv uses a macro to check the result from randomization. First of all, I will define the macro. Tick define. In Verilog also we have used define. Tick define sv underscore rand underscore check. Inside the bracket I will put, actually this R is the function packet class handle dot randomize. So that class handle dot randomize, not of class handle dot randomize. If that is successful, then nothing is coming, means I am not displaying the result of all the fields. But if it is unsuccessful, then what I will do, I am having the display statement $display %s. %s will give the string. First field, what is there? Tick underscore file underscore. That means file name from where the display statement is coming, that I have to put. Such a big design, test bench code. Okay, all the components, I do not have accessibility. I need to look into the log file to check what is the error and from where it is coming. So %s will give the file name. After file name, line number, tick underscore line underscore. That is why this is the format string for that, %0d. So this will display the line number. Then the randomization failed, that will come. Then R. Randomization failed for which class handle? So it is failed for which one will be passed to the sv underscore rand underscore check define. Okay. This way we can display the randomization failed message. We can check for the randomization. Do while loop is there, no? Do, begin, end, then while. This is how the macro is used. Tick sv underscore rand underscore check inside the bracket p.randomize semicolon. And when the display will come in the log file, it will show like this. Test.sv line number 13. Randomization failed message. Randomization failed is coming for which particular class handle? Randomization. So p.randomize. Now we will show you how the example of this usage of sv rand check in a program block of test. See, program automatic test semicolon. I have an array. So I have a data type unique array. User defined data type, it is a class UA semicolon. Inside the initial begin then what I am doing, UA equal to new 50 means I am constructing UA unique array data type. I am constructing. It is actually a class based. It is a class, actually instance of a class. So user data type, maximum array size I am putting as 50, new 50 semicolon. Okay. Then I am using the repeat code. Inside the repeat double bracket I have put 10 times the begin and statement. Block of begin and statement will be run 10 times. So inside the begin and tick sv underscore rand underscore check bracket ua.randomize. So this particular class handle.randomize is called. So here we create a random array. ua.randomize means I am creating a random array. Now after creating the random array, I am checking, what I am doing is that I am checking whether this is passed, randomization passed or failed. So that is why I have put a macro for that. Tick sv underscore rand underscore check. Okay. Then if it is failed, in the log file we will see that yes, it has randomization failed, and for what instance or class handle ua.randomize it will display. Now the fields of the class ua.display, when I will do, fields of the class will be displayed. For the begin statement I have an end, and initial begin I have end here, and this end program is for program. Okay, hope I am able to little bit give you information about the randomization in system Verilog. What is Randc, rand, randomize function. Okay, hope you have got an idea of it. If you like the video, share with your friends. Please subscribe the channel and have a very nice day. Bye bye.